Hi everyone. Today I'm going to take you step by step on how to read a time distance graph. This is something that you're going to be expected to know, so I want you to pay close attention. Again, if you have to, you can always pause, rewind, or rewatch the whole thing again. So here we go. So here we have a time distance graph. Every graph has an X and a Y axis. On your X axis here is your time. And then on your y-axis over here is your distance. Now please don't forget that every time you set up a time distance graph, or whenever you read one, you're going to notice it has a unit of measure. In this case, distance is being measured in kilometers, and over here time is being measured in hours. But it can be whatever you choose it to be. If you were to make your own, time can be in seconds, minutes, days. It all depends on what it is that you're measuring. Over here, distance can be anywhere from kilometers, meters, centimeters, millimeters, miles, again, whatever it is that you're talking about. And then the lines here are what is being measured. Okay, so here is our next time distance graph, and what this is measuring, when you see a straight line here, is an object that is moving at a constant speed. So if we were measuring a car moving and it was going 35 miles an hour, then it's constant. It's not slowing down, it's not speeding up. It's just a constant speed. So we can see here that our object traveled 5 meters, and if we wanted to know how long that took, we would come over to the end here, approximately, travel down, and it took approximately 5.5 or 5.5 seconds to travel 5 meters. And that's how you would read that. So anytime you see a straight line like this, the object is traveling at a constant speed. Now, depending on the slope of your line, you can determine if your object is going fast or slow. So for example, this object here is traveling at a constant speed because it's a straight line, but it has a much steeper slope than this object over here, which again is traveling at a constant speed, but because the slope is not so steep, it is traveling slower. So for example, if we were to look at the steeper slope, in 3 seconds, whatever object this was that was moving, it traveled 12 meters. So in 3 seconds, this object was able to travel 12 meters, whereas in 3 seconds, this object was only able to travel 1 meter. So it's much, much slower. Kind of like the race between the rabbit and the hare. This would be the rabbit, or the rabbit and the tortoise, sorry. That would be the rabbit, and then this would be the tortoise. Okay, now objects are not always traveling at constant speeds. They're slowing down, they're speeding up, turning direction. So here we have an object that is traveling at a constant speed, but then after approximately 3 seconds, and after only going about 4 meters, it stopped. So when you see a horizontal line like this, the object has stopped. It's not moving. So from 3 seconds to approximately 9 seconds, it was still. So for 6 seconds, it did not go any farther than 4 meters. So constant speed, object stopped, did whatever it was doing, stopped to pick something up, a person tying their shoe. They stopped for 6 seconds. Okay, now we're just adding on to our time distance graph here. So now we have an object that was moving forward at a constant speed for 3 seconds. It traveled 4 meters. Then, from 3 seconds to approximately 9 seconds, it did nothing. Again, maybe it was a person who stopped to take a phone call, person found something on the ground, whatever it was, they stopped. Then they started moving again. Again, they're in a forward motion, and in this case, they are again moving at a constant speed. Now, you're not always going to see lines that are straight. Sometimes you'll see curved lines. So if you see a line like this, here's our object, starts at 0. This is our starting point. We're slowly moving, but as the line is getting steeper, this curved line, the object is speeding up. So perhaps it was a car at a red light. Whenever you put your foot on the accelerator, you start going slow, and eventually you speed up to the speed that you're comfortable driving at. So any kind of curved line like this means the object is starting out slow and then speeding up. Okay, in this case, it's the opposite. Our object has started out fast. See how our slope is steep? And then it starts curving off. It's going slower and slower and slower. And if this were to keep going and it ended up as a horizontal line, that means our object would have stopped. Okay, I would suggest at this point that maybe you pause the video and take a moment to try to narrate what you think is going on here. What is this object doing? Think of it as maybe a person walking out the door, and what are they doing? Okay, so hopefully you have paused it and tried to do this on your own. So let's look here and see what's happening. First we have our, we'll say a person, starting out here at their home. They leave the house. They leave the house and they slowly move at a constant speed for, well, I don't have, this is very generic, so I didn't put any unit of measure here. So our person is moving at a constant speed from home to point A. Maybe it's the end of the driveway. Then they stop. For approximately 2 seconds, they are not moving. Then they begin moving again. Again, they are going at a constant speed. But here at point B, our line is totally turning into another direction. All right. What this is telling us is that our person who was walking at a constant speed stopped and started walking back again. So if it was a person who left their house, maybe they realized, oh, I forgot my keys at home. So they're actually turning around and going back. Again, they stopped for a moment, approximately 2 seconds, if our unit of measure was seconds. They stopped, and then again, they started walking back to their original destination. So if your line makes it all the way back down to the x-axis again, that means your object has returned to its original place. So if it was, the object started out at their house, then now they have returned back to their house. All right, let's try another one. Okay, so here's a little narration here. So we're going to decide, okay, what is Tom doing? So Tom took his dog for a walk to the park. He set off slowly, then increased his pace. At the park, Tom turned around and walked slowly back home. Okay, so let's take this step by step. The first step is he set off slowly. So here's our line. Constant speed, slowly. Next, he increased his pace. So see, we have a slope that's not very steep, and then our slope becomes steeper. So he picked up the pace, but he's walking at a constant speed here. Then Tom turned around and walked slowly back. This is Tom here, and now that our line is returning back to the x-axis, the person has returned back to their original destination. Okay, let's try another one. And then you guys are going to be doing this on your own. Okay, Kelly went for a jog. At the end of her road, she bumped into a friend, and her pace slowed. When Kelly left her friend, she walked quickly back. So here we show Kelly went for a jog. So she's slowly jogging at a constant rate. Then she bumped into a friend and stopped to talk, which is our horizontal line here. Object is not moving. And then she left her friend and quickly walked back. Notice that when she's jogging here, it's slower than when she was moving back. So actually it looks almost more like she was walking here and jogged here because this is a steeper slope. Anyhow, this is how you read the distance time graphs. You will be given more of these to look at, and please feel free to refer back to this anytime you have problems, or see me in class and I will definitely help you out. So see you guys in class.